So this is lesson 5, representing exponential decay. For 5.1, we have two other tables. We're going to use the patterns we noticed to complete the tables and then show our reasoning. So, what do you guys think the pattern is for table A?
It looks like 7.5.
7.5?
Yeah.
So what am I doing with 7.5? We're adding it? Adding it to what?
To itself?
Yeah.
After multiplying by.
Do what?
After what you're multiplying by.
Wait, what are you multiplying?
The x values?
The x values, so we're multiplying 7.5 by the x values? Does everybody agree with that?
Yes. Because there's 1 there and it would have been 7.5.
It would have been what?
If we're timesing it by the x values, 1 times 7.5 would be 7.5.
Right.
So,
But what are we adding to it? We're adding something to it. There's one thing that we're adding. What?
exponents?
No. Well, there's not an exponent on this one. So if x is 0, what is 7.5 times 0? 0. But our y value is 2.5. So what am I adding to it?
0.5.
2.5. So we're going to say 2.5 plus 7.5x equals y. Does that work for 1 and 10? So if I plug in a 1 for x and a 10 for y, does that make that statement true? What's 7.5 times 1? 7.5. What's 7.5 plus 2.5? So does 10 equal 10?
Yeah.
Yeah. What about 2? I'm going to write this down this time. That way I'm not just talking through it.
Wouldn't you add 10 plus 7.5?
7.5 times 2 equals 17.5. So I just plugged in the 2 for the x and the 17.5 for the y. What is 7.5 times 2? 15. So 2.5 plus 15 equals 17.5. What is 2.5 plus 15? 17.5. Does 17.5 equal 17.5?
No. Yes.
No. Yes, it does. You just wanted to say no? All right, so if I plug in a 4 for my x, so now we actually have to solve this. So I'm going to erase this work that I just did right here. And we're going to plug in the 4. So we're going to have 2.5 plus 7.5 times 4 equals y. We don't have a y value. We're going to find it. So what's 7.5 times 4? What was 7.5 times 2?
7.5.
So it would be 30. So 2.5 plus 30.
Wait, how is 7? Oh, 7.5.
Yeah, 7.5. We know that 7.5 times 2 is 15. 15 times 2 is 30. That was just like a faster way to do it. If you want to do, you can do the, you can write it down and do 7.5 times 4 if you want to. All right, so what is 2.5 plus 30? What? 32.5. Okay, now we have 25. Big numbers. So we have 2.5 plus 7.5 times 25 equals y. So let's go over here to the side and do 7.5 times 25. What is 5 times 5?
25.
What is 7 times 5?
35.
Plus 2.
37.
Would it be 187.5?
Did you use a calculator?
Mm-hmm.
Put it up. 2 times 5, what is that?
He's like hiding his phone.
10. You guys can do this kind of math. 7 times 2 is plus 1. So we add that. Then we have 5 plus 0 is 5. 7 plus 0 is 7. 3 plus 5 is... And then we have a 1. And we move our decimal place over 1 there. So we move it over 1 here. It is 187.5.
Honestly, I haven't done that multiplication in years. Yeah.
Well, that's why we're refreshing your memory, because you can do this. You don't have to use calculator. All right, now we have table B. So, what do you notice here?
That they're usually going up.
It has the same starting point.
It has the same starting point, so I'm going to use 2.5 again, somehow, right? Okay. 2.5. What is getting added to that at 1?
7.5.
Okay, what about the next one? 30. So am I adding something or am I multiplying by something?
Multiplying.
Okay, what are we going to multiply by?
Let's say 5.
4. How'd you get 4?
Because it went from 10 to 4, 10 to 40, which is times 4, and then 40 to 160, which is times 4 as well.
Oh, nice. So we noticed that we went from 10 to 40. So you multiply by 4. From 40 to 160, you multiply by 4. Do you guys see that?
Oh yeah, it's like the exponents in a way.
Right. We're multiplying by 4 each time. So if I have 4 to the 0 power, what do I get?
0? 4?
Or 1.
You get 1. Anything to the 0 power is 1.
Oh yeah.
So we get 2.5 times 1. Is that my first column? 0 and 2.5. So if I plug in that 0, we get 2.5 times 1 is 2.5.
It's laggy behind.
Sorry. There it goes.
When the math lags.
Okay. So if our exponent is our x at 0 and our y is the answer, then does that work for 0 and 2.5?
Mm-hmm.
Yes. What about another one? Let's do 2. So if I do 2.5 times 4 to the second power, what is 4 to the second power? 16. Okay, so 2.5 times 16. Let's do... What's 5 times 6? 30. What's 5 times 1? 5 plus 3 is? Drop our 0 down. 2 times 6 is? 2 times 1 is? Plus 1? 3. And then we're going to add 0 and 0 is 2 and 8 is, and 3 and 1. Move our decimal place over. Is that what we have for 2?
Mm-hmm.
All right. So now we're going to plug in our numbers that we're supposed to be finding. So if we have 4 to the 4th power, what is that?
2.5 times 4
Ooh.
to the power.
Hold on. 2.5 times 4 to the 4th power. What's 4 to the 4th power? Does anybody know?
6. No.
So 4 squared is 16. So we're going to multiply 16 by 16.
15 times.
Does anybody know that square? 16 squared?
I know 15 times 50, not 16 times 50.
Well, then let's do it. What's 6 times 6? 6 times 1.
6,
Plus 3.
8.
9. 0. And then we have 1. So I'm just going to go ahead and just write down 16 because that's an easy one. 6 plus 0 is. 9 plus 6 is. And 1 plus 1 is. So 256. Then we're going to take 256 and multiply it by 2.5. Okay. 6 times 5. 5 times 5. Plus 3. 5 times 2. Plus 2. That actually looked like an 8. Okay, drop our 0 down. 2 times 6. 5 times 2. Plus 1. And 2 times 2. Plus 1. Drop down our, okay, 0 plus 0 is 0. 8 plus 2 is 1 plus 2 plus 3. 1 plus 2 plus 1. 4. Okay, 5 plus 1.
6.
Move our decimal place over. It is 640. Okay, for this next one, we're not going to do the power of the 25th because that's a lot. We're just going to write in here 2.5 times 4 to the 25th power. I did do this on a calculator whenever I was writing out my notes. The answer here is 2.815 times 10 to the 15th power. And that is a rounded number. But that's really big, and I did not expect you to try to do that in your head. Because I know that's going to be big. All right. Now we have algae in bloom. Or algae bloom, however they want to say it. In order to control an algae bloom in a lake, scientists introduced some treatment products. Once the treatment begins, the area covered by algae, A, in square yards, is given by the equation A equals 240 times 1/3 to the t power. Time t is measured in weeks. In the equation, what does 240 tell us about the algae? It what? So it's the initial amount of square yards that the algae covers. Initial amount of square yards covered by algae. Okay. What does the 1/3 tell us?
It's telling us that a portion of it was
A
gone.
third of the bacteria is measured in TB.
Okay, so a third of what?
Or that algae, sorry.
Okay, so the area covered is 1/3 of the area covered the previous week. The previous week. Does that make sense? Okay, so the area covered is 1/3, oops, not 1/2, 1/3 of the area covered the previous week.
How does that make sense? 1/3 of the area covered is 1/3 of the area covered.
Okay, so we're multiplying the total area by 1/3. So if I multiply, let's say it covers 9 square feet. If I multiply 9 by 1/3, what is my answer? It's 3. So 1/3 of it, we're making, it's going to be smaller every time we multiply by 1/3. So week 1, week 0, when we first start, if we have 9 square feet, at week 1, we will have 3 square feet. Because we're trying to control it, we're trying to keep it from expanding, and we're trying to get rid of it, it sounds like, right? Because they're treating it. So it's going to keep going down. So at week 2, after we had 3, what's 1/3 of 3? 1. So at week 3, we would have 1 square feet. Does that make sense? Is anybody really confused?
Not anymore.
Okay. All right, so now we are going to create a graph to represent our equation. So A equals 240 times 1/3 to the t power when t is 0, 1, 2, 3, and 4. Think carefully about how you choose to scale the axes. If you get stuck, consider creating a table of values. So we're just going to go ahead and start with making a table of values. So what I want you to do is kind of like the tables we have at the top, like table A and table B. So we're going to say T, or weeks, and we're going to draw a line underneath it all the way across. And then we're going to say A for square yards. And you can abbreviate there if you want to. You can spell it out if you want to. But we can't do like a vertical table like we typically would because of the spacing we have here. So we're going to do 0, 1, 2, 3, and my spacing is going to be off, 4. That's okay. Try to make it to where it doesn't go into the graph, but I made it go into the graph yesterday as well. So at 0 weeks, how much is covered in square yards? 240. At 1 week, how much is going to be covered? So what is 1/3? So we'll have 240 times 1/3 to the 1 power. So we're looking at 1/3 of 240. So what is 24 divided by 3? 8. So it will be 80 because we just dropped down our 0. Now we're going to take 1/3 of 80 for the next week. So how many times can you divide, how many times does 3 go into 80? 20 what? So technically this would be 240 times 1/3 squared, or you can say 80 times 1/3. So if we divide 80 by 3, you should get 20. Does anybody know? 7. It's 27. Here, look. If you divide 3 into 80, you're going to get 2. 2 times 3 is...
I don't know how to divide. I think you
Okay. How many times does 3 go into 20?
8, no.
I think it's actually 6. So this one right here is rounded. Because 6 would be 18. If you keep going, you're going to get 20 again. So it's going to be a 6 repeating. So we're just going to round it to 27. Okay? All right. What about for 3 weeks? So 1/3 of 27 is 9. What is 1/3 of 9? 3. Sorry if you can't see that very well. All right, so let's graph this. We need to be to where we can see 4 on here. So let's see here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So every 4 is going to be 1. So let's do, so this is going to be 1, 1, 2, 3, 4, 2, 1, 2, 3, 4, 3, and the last one is 4. Okay. Then, let's see here. We cover, the most is 240 square yards, right? Also label this down here. This is going to be time in weeks. And over here is going to be area in square yards. Okay, so I'm assuming this is a perfect square and there are still 16 notches, and we have, so 240. Let's do by 50s every 3. 1, 2, 3, so 50. I think this will work. 1, 2, 3. 100, 1, 2, 3, 150, 2, 3, 200. So I'm going to go ahead and erase this so that you can see where we're at on the graph. So 250 is going to be right here. So now we're just going to graph our points. So we have 0 to 40. So we're going to go over 0, which is on the y-axis, and go up to 240, which should be somewhere in here. Okay. Then we're going to go to 1 and go up to 80, which is going to be way down here. And again, this is just approximate. It may not be perfect. It's what? Can you not see the pink dot?
It's just slightly delayed. So.
Yeah, that just maybe be the air chain. So at 2 weeks, we have how much in square yards?
27.
27. So we're going to go, let's see here. That should be,
In the middle, maybe?
yeah, somewhere in there. What about the next time? 3 weeks. 9. So we're going to be probably down here. And lastly, our 4th week, we have how much?
3. So way down there.
So way down there, real close to 0. All right. How many square yards will the algae cover after 2.5 weeks? So if I look right here, I can say, I know that it will be less than 27 yards. Do you agree with that?
Mm-hmm.
Okay, so it's going to be less than 27 yards squared. What will it be more than?
9.
More than 9 yards squared. So because the area is decreasing, and it's got to be between those two numbers, what would you guess is a good place for that number to be? 20? I would say that's okay. My thing says that a good guess is going to be between 15 and 20. So between 15 and 20 would be a good guess. All right. Let's go to the next page. All right, so we have insulin in the body. A patient who is diabetic receives 100 micrograms The graph shows the amount of insulin in micrograms remaining in his bloodstream over time in minutes. Okay, scientists have found that the amount of insulin in a patient's body changes exponentially. How can you check if the graph supports the patient's claim? So what could we do here?
In the minutes,
Okay, so look at how much it changes between the minutes. What do you notice between point 1 and point 2? So if I look at 190 and 281, what do you notice there?
in only possibly 2 minutes, it went down from 90 to
Okay, so it went down by how many? 9. Okay, what about between 81 and 72.9?
Went down 9.1.
Okay, so it went down 9.1? You sure it was 9.1?
They should be 10.
I'm thinking it's 8.1. So we went down 90 minus 81 was 9. 81 minus 72.9. So that will be 10. This will be 10. Be 7. I believe it is 8.1. So let's just say here that if insulin decays exponentially, that means after each minute, the same fraction of insulin will decay and remain. So if I was looking at this as a fraction, what fraction what fraction stayed? So if I said 81 over 90, if we pulled a 9 out of both of those, what would we have? What times 9 gives me 81?
9 times 9.
9. Okay, what times 9 gives me 90? 10. So if I multiply, or well, actually no, let's look and see if this works. So if we do 72.9 over 81, let's see if this fraction will work. So we have 72.9 and I divide it by 81. We get 0.9, which would be 9/10. So that works. So it looks like what we're doing is multiplying our original amount by 9/10 over and over and over. So that's how it's decaying, okay? So how much insulin broke down in the first minute? So what is the fraction of the original insulin is, okay, what fraction of the original insulin is that? I think we already kind of went over this. So we went down how many grams? Or micrograms? I think what we're looking at here,
It went down 10 times.
so right here, that's what you're talking about. We went down 10 micrograms. How much of that was the fraction of the original or the initial injection?
Can I fill out his notes when he's in the bathroom? So he doesn't fall behind.
Okay, so 10 divided by 100 gives me what fraction of the original insulin?
Wouldn't it be 10?
It would be 1/10 of the original insulin. How much insulin broke down in the second minute? So, we've kind of already done this, but now we're going to say, what's the difference between 90 and 81? I think we already did that, right? Because that was that 9 micrograms over here. Okay, so if I take 9 and divide it by our amount from up here, the 90, what does that simplify to?
1.
1 what?
Just one.
No,
It's going to be 1/10 again. Because you can pull a 9 out of both the numerator and the denominator. Okay? So, what fraction of insulin remains in the bloodstream for each minute that passes? So, what fraction of insulin remains in the bloodstream for each minute that passes? And then you're supposed to explain your reasoning. We've already kind of calculated this. So, this is our 9/10. So, for each minute we lost, or we absorbed, I guess that's a better way to say it, 1/10. So I'm going to take out that loss. 1/10 broke down of the insulin. Broke down. So each time that means 9/10 remains.
it's decreasing pretty fast.
What?
It's decreasing pretty fast.
It is decreasing pretty fast. That's why people who have insulin issues, sometimes that can be either having too much insulin or having too little. That's why they have to do injections so frequently. So, we're going to complete the table to show the predicted amount of insulin 4 and 5 minutes after the injection. So, how do you think we're going to find that out?
You divide by 7, anything else.
So we're looking at the insulin in the bloodstream. What am I going to multiply 72.9 by to get what will be at 4 minutes? So, what?
3.
Not 3. How much remains in the bloodstream? 9/10. So we're going to multiply that by 9/10. So I'm just going to do that on my calculator real quick. We're going to do 72.9 times 0.9, because that's what 9/10 is. That equals 65.61. Okay, so now we're going to multiply that 65.61 times 9/10 to get from minute 4 to minute 5. That is going to be 59.049. We're going to round that. Actually, nah, we'll just leave it. We'll do 59.049. So, describe how you would find how many micrograms of insulin remain in his bloodstream after 10 minutes. And we're going to use... And we're also going to say after M minutes. So what would we do? What was the initial amount of micrograms in his bloodstream? 100. Okay, what are we multiplying by? 9/10. So that's our remaining amount in the bloodstream. So with our 9/10, we're multiplying that by how many what? Okay. How many times are we multiplying by 9/10?
10.
10. So to the 10th power. I don't believe they want us to solve that. We're just going to write how we would find out. So we would multiply 100 times 9/10 10 times. Or to the 10th power. For m minutes, what would our equation be?
Then, no, wait, 100 times 9/10 with exponent of m.
Exponent of m. There you go. Good job. Okay, so you guys do have homework tonight. Lesson 5.5 practice problems. Those are on Canvas.
Easy, baby.